So question number 3 is an integration by recognition because we were told to take this derivative, hence use that answer to find this area. Now this area here will be the integral from 0 to pi on 2 of x cos of x dx. Now I can't take that antiderivative because there's an x there and an x there. So that's why I've been given this to be able to work with. Okay, so let's do that. If I'm going to take this derivative, it's a product rule. So u equals x, so u dash equals 1, and v equals the sine of x, which means v dash equals the cos of x. So d dx of x sine of x will be this times this, x cos of x, plus this times this, which is sine of x. That's part A done. Part B, I've got to use this information. So what am I doing? I'm saying that, so I'd like to anti-differentiate both sides with respect to x. So the antiderivative of the derivative of this gives me that equals the antiderivative of x cos of x dx plus the antiderivative of sine of x dx. Now I know that the antiderivative of sine is negative cos of x, and that's the antiderivative of x cos of x dx, and this is x sine of x. And I'm looking for this. So this is what I'm looking for, and I can see it there. So if I pick this up and move it to the other side, I would have x sine of x plus cos of x equals the integral of x cos of x dx, and that's exactly what I want. So the integral from 0 to pi on 2 of x cos of x dx should equal square bracket from 0 to pi on 2 of this, x sine of x plus cos of x. Subbing in that top terminal first gives me pi on 2 sine of pi on 2 plus cos of pi on 2, and then putting in the bottom terminal I minus 0 times the sine of 0 minus the cos of 0. Pi on 2 times 1, because the sine of pi on 2 is 1, plus 0 minus 0 minus 1. So my answer should be pi on 2 minus 1 square units as being the area shade.